I actually talked about temporal modeling the first time at this conference in 2015. I will probably talk about it for the rest of my life. I keep experimenting and changing how I do it, so this might be a disaster. You can leave now actually and go to a better talk. The good news is I will be talking about this for the rest of my life, so if you come back in a few years, I'll have a better version. So about me, I'm Mathias Verraes. I run a small boutique consulting, software consulting agency from Belgium, but we're international. We consult for all kinds of companies on software modeling, design, analysis, quality, that sort of thing, architecture. So temporal modeling, we can look at the world in two ways, right? We can look at systems, any system, a human system, small system, large system, the economy, natural systems, nature. We can look at it in two ways. One is to look at it as things first, right? The other way is looking at it as processes, things behavior happening over time. In software, I think we are too constrained to looking at the world as things first. I mean, we look at behavior, of course, but we look at things first. Things, structures, data structures, schemas, types, entities. All these things are structural models. We look at those things first, and then we build on top of that. What I'm going to try to pitch you is to look at the other way to use temporal modeling, to look at our systems as behaviors first. What we do is we analyze a problem and we translate it into things. We find nouns for it, not just the names of objects, but everything, even components, bounded context. If you do DDD, people call them after things, right? They call them the customer context or something like that, or the order context. Those are things. And then after we found those things, that's when we add relationships to it, right? You probably know this sort of drawings. These could be objects, this could be components in software architecture. Relations are still structural, right? Relations are about this thing is a, or has a, or composes of, or uses, or depends on. And what you get is you build bigger structures. You build bigger things composed of things. That's the way we look at it first, and then as a last sort of step, as a last addition, we start thinking about behavior on top of that, right? How do these things change? How do these relationships change? The problem with these kind of pictures, for example, these kind of diagrams, is they don't really tell us much about it. In a picture like this, you might have stuff like, you might describe these relationships and these things better than I have drawn here, of course. But it doesn't really tell me how these things come into being, how they stay, how they evolve, how they are replaced. For example, in this drawing, well, of course it's oversimplified, but does this thing here always appear at this, is created or added at the same time as these other things? Is it added later? Can it be replaced? How often does it change throughout the course? This picture doesn't really tell me that. And the names in our system are the smell of this, right? If the reason we name our components and objects and microservices after things is because we look at the world that way. The opposite view is to look at events first. Events, processes as our main building block. An event is something that has happened, right? Something that has happened at some granular point in time. Typically something that the business is interested in, that we care about. A customer bought something, this happened, that happened, right? In temporal modeling, that's where we start. We look at all the things that have happened. We model that, we visualize that, for example, using event storming. And then on top of that, we start looking at, well, the way these events combine, that's a process, that's our next building block. That's this and this and this thing happen in this order or are constrained in this order. or happen together, or can happen in different orders. But we look at a process as the next building block on top of that. And then only as a sort of last level, as a consequence of that, we start looking at things. Things are the consequence of the events that have happened over time. It's sort of it's all the same, it's the same, right? You can translate from structural models into temporal models and back. They're just two ways of looking at systems. They're not wrong or something. But it's sort of inside out, right? It's not, we have a customer, and that customer has orders, and now we're going to think about how to add the order. An order is placed, and then we think about, well, what happened before, what happened after? That's a process. How do we get to that point? What events happened before and after? And then we start thinking about, well, what kind of structures can we derive from that? Can we interpret from that behavior? And I take this very far, right? Many people are now building more event-driven architectures. I think there's still too much looking into, a thing emits an event, as opposed to events add up to things, right? This is the same way that these ideas exist in philosophy, etc. You are the sum of everything that has happened to you, right? It's the event first. The reason I think that we shouldn't drop structural modeling, but we should look at temporal modeling much more. Now I'm a little bit stuck. Let's see if we can move to an example first, maybe. Actually, I forgot to mention that. If you want to ask questions, please do. I'd rather have a discussion than just me talking. This is why I don't use slides, because then I'm stuck to the structure of the slides. So let's have a simple example. Let's say that we have an account in a SaaS system, right? And customers can cancel their subscription. So I have an event, subscription was canceled. So we look for these events, and we see what happens after, right? We want to have, in this particular example, we want to not end the account straight away, because if they cancel, we actually want to try to see if we can convince them to come back or to stay. So we don't actually delete their account yet, but we give them some time. We schedule an expiration period of 30 days. Right? So we can write that down as an event that has happened. We have an expiration period was scheduled. If you can't read it from the back, just look at the colors. That I'll explain as I'm talking. So, and then at some point, 30 days later, the reconsideration period has expired. And that's when we actually have the event that says the account was cleaned up. Right? So we start from each of these interactions, and then from that language, I'm now, of course, very constrained into this single process. This is already filtered to only be events for this specific process. But we look at this model, and then we start thinking, okay, this belongs together. This is the kind of structures that we can use to make this work, right? So we can think, do we need, for example, do we need a subscription entity or service or something? Do we need an account service? Do we need, as a last resort? Is this making sense so far, by the way? Because you're all staring at me. Okay. So one of the points I want to try to make here is that these events are much more fundamental than these entities, in the sense that entities are chosen, right? An entity is a modeling choice. All models are wrong, and some are useful. You probably know that quote. But the events are much harder to argue with. The events are fundamental in the sense that it's a very granular point in time where something has happened. There is, we cannot say the customer has not canceled the subscription, because they have canceled the subscription. There's nothing else in here there's nothing in this event that is an opinion. The only opinion is, should we actually allow that? That's a business choice. Here, this structure is always opinionated. This may be hard to see, because if you are modeling, if you're designing software, you might feel that the structures that you build are the only way to do it, right? But then maybe you've had this experience where somebody has a different model for something, a different way of structuring it. And the moment you see the new model, you cannot unsee it, right? Suddenly it clicks, and then you feel, oh, how could I have not understood this before? Now it's just the way I see the world, right? Not just in software, everywhere. This is the magic of a breakthrough, right? When you suddenly see the world in a different light. That's because these models are opinionated. It's a choice. Let me give you a simple example. In temporal modeling, I said everything is a process now. Processes are first class, things are second class. So when I say customer, what I actually mean is a customer is a process. A customer is a life cycle. What is a customer now? A customer is the event where somebody signed up. They bought something else, or they put something in the shopping cart. They come back a week later and actually buy it. We ship it to them. All these events, this has happened, adds up to the concept of customer. Why do we have the concept of customer? Because we care about the relationship between those events over time. I care that this purchase that happened in the beginning of the year and this purchase that happened at the end of the year, they are somehow connected because I'm interested in the fact that this is the same customer who bought this, right? So a customer is a process, a life cycle that starts at the first purchase or subscription or whatever, and ends with the moment they left or they stopped buying things, or and we can look at everything that way. So if a customer is a process, and if it is because we choose to be interested in the connection between those events, we might also not be interested in the connection between those events. There are circumstances where you might have an e-shop where you don't care that these two purchases are done by the same person. So I have no customer entity, right? That's what I'm trying to say here. This customer entity is a choice in how to group things, in how to put things together. You know, why do I put the shipping address in the customer? I could put it in the order. I could put it somewhere else. All of those are structural choices. Nothing wrong with that. It's just, you know, and one of these structures might be better suited to solve one problem. Another structure might be better suited to solve another problem. But my feeling is that this is because these building blocks are not sufficiently fundamental, right? These structures are chosen. The events are discovered, if that makes sense. You discover that in our model, we need this event to capture the fact that something happened that we care about. And then we look at process. Process is these things belong together, these events belong together. And the sum of that, we can look at things as a way to express that. In fact, I go even further. I don't name the things as things anymore because they are processes. For example, I don't call it invoice. I might call it getting paid, because this object now doesn't represent the invoice as an artifact. The object represents that I'm trying to get paid for this thing, right? And one of the steps in there might be sending some document to somebody to tell them, hey, this is the money you owe me. But the important thing is that these are events. Invoicing or getting paid or whatever I call it after the process. The process involves making the invoice, sending the invoice, getting payments or sending reminders, getting partial payments, etc. Right? So it's a process. I care more about the process invoicing than about the artifact invoice. One of the problems that happens in these sort of models is you have the invoice object, and then people start adding more and more stuff to it because, oh, we also need to track partial payments. Oh, we also need to track reminders, etc. And these objects grow. Very typically, it's sort of the core concepts in your domain have, in legacy systems, are the largest objects or components, right? If you have let's say you have a car rental system, then the car object, I guarantee you, it's 10,000 lines in the legacy system. That's because there's no clear reason of why to put things in there or not, and it's always easier to just add it there. With temporal modeling, you're much more forced to look at it, because we look at the process, we say, well, this belongs together because it is in the same process. It's not arbitrarily, it's not by choice, it's a consequence of the fundamental events that we discovered. Is this making sense somehow? All right, excellent, smart audience. That makes it easier. I don't want to make, so you should look into event storming, and I don't know if Alberto talked about it yesterday, I wasn't in this talk, but he sort of coined it, and bug him about it if you get a chance. But this is basically what I'm doing. Event storming to me is just a good technique that you visualize processes over time and events over time, and you can collaborate, etc. So it helps to discover this stuff. But it's discovery. It's almost more discovery than modeling, or at least the first part is discovery of events, and then you start looking into process. So this one is now I only have one example, right? So what I do in this sort of modeling sessions or event storming sessions is try to find other variations of the process and to learn more about what we need, of course. For example, here, of course, we have, the account was cleaned up, but if we allow a reconsideration period, we should make sure that they can actually reconsider, right? So this should be in here. I'm now going to add the yellowish ones are events, or orange-ish. The blue one is a command. A command is another type of message that says, do this thing. It declares an intention to do something. So here, the customer says, reconsider. Well, actually, before the reconsideration period has expired, they say reconsider. I can express the outcome of their intention. So now we have to actually, do this thing. The customer clicks a button to reconsider, and then the system responds by doing the thing, the event, right? If you do event sourcing, a lot of this should be very familiar as well, by the way. But all of this is, you can do this kind of modeling even if you're doing very traditional object-oriented systems. It's an analysis technique as well. So customer has reconsidered, and then of course instead of account was cleaned up, we should, let me see if I have that one. Oh no, sorry, there's nothing. This is just the end, right? So this is the end of process. The subscription was canceled, expiration was scheduled, we reconsider, the customer has reconsidered. But this one still happens here, so we need a rule to make sure it doesn't happen. So that's this one. I use red-ish for that. So before we clean up the account, we should have a rule. The rule says, don't close the account if the customer has reconsidered. And then this event doesn't happen. So based on that rule, we basically have two different outcomes, except that the first outcome is nothing happens. So it looks like this, right? This is just to indicate nothing happens, no event. So rules are another sort of fundamental thing in this. Again, here, this is like the last thing you put on the model, if you ever put it on there as well. If you have ever drawn these sort of, structural models or object models, or before coding something or after, how often do you actually put the rules on there, right? Probably, I've never seen anybody do that. The rules are part of the reason why we built the system, right? To automate the decision making, so that we wouldn't have to have some human looking at, oh wait, 30 days have passed, now I'm going to do this thing. Now the machine can do it, right? That's what rules are. I call them rules as a very broad term. They're constraints, invariants, business rules, whatever. So now we're basically saying that well, I should put this one back in there. Let's move this. It's business logic, yeah. Yeah, but so I tried to, I still haven't found the perfect term, but I tried to find a more general term, because there are things that are not really business logic. For example, well, take the car rentals. If I rent you a car, I cannot rent that same car to somebody else at the same time, right? That's like a physical constraint. That's not really a business rule, because it's not a business who decided, hey, you know what we should do? What would be good for our business if we only rent the car? We just can't, right? Well, we could try, and then the customers would have to fight each other over the car, which is probably a bad business decision anyway. So maybe it is a business rule. But so it can be physical constraints, it can be business rules that are imposed, it can be things like risk mitigation, right? Why do we want to get paid before we ship the good? That's not really a business rule, that's more like a risk mitigation policy or something, because we think that if we ship the good, we might not get paid, right? In fact, this is besides the whole temporal modeling stuff, but a very good analysis technique is to look for how does this business deal with risk, right? We could only give you rent your car if you pay up front, and we don't know how long you're going to, or how many kilometers you're going to do with the car. So I'll charge you 10,000 euros. So I'm sure that I will get paid for every kilometer that you drive. That's zero risk, but that strategy is so extreme that nobody will want to pay me 10,000 up front to do a one-day trip, right? At the other end, we could say, well, everybody can just, here's the keys, grab cars if you like, afterwards give us some money. That would be the other extreme of the risk. We assume all possible risk. And somewhere in between there is the perfect balance of what is the level of risk that we want to take, and how does that balance with making more money or getting more customers or whatever we're interested in. And if you understand how a business thinks about this fundamentally, you understand more about how the business works. You understand that domain better. You can design better software for it and design better models for it. So for me, this is like a domain-driven design heuristic. Find the balance between risk and money making, and understand how that works. And then you don't even need to understand all the business rules anymore, because the business rules should be consequences of that risk, that appreciation of risk in a sense. Anyway, that's stuff that I do not in the. That's like if I model with a client for a couple of days, then I started asking these questions and see. Then you can point to the model, and if you have like, well, a room like this, I cover this in post-its in one day. Every wall, every corner is full of post-its, and then you can point at things. You can say, well, we now figured out, maybe during day 2, this is how you see yourselves, how you want to deal with risk, how you want to make money, what your goals are, that sort of thing, right? How does that rule actually work with that? That rule doesn't match how you see yourself. We're building the wrong thing here. We're focusing efforts on something that we actually don't care about if we start thinking about it. Why does this happen? Well, because people fall in love with the feature they invented without caring if the feature actually is helpful for the business, that sort of thing. Here, I think it's a nice one because maybe we can use those 30 days to have a salesperson call up the customer and say, hey, why did you cancel? We can do better. It's not you, it's us. What would make you stay? Let's give you a discount, whatever works. And they stay, and then, let's see. This we now have a very simple model. And then, because I visualize the events over time, because I visualize the process, I think it's much easier to reason about how it behaves, even with non-technical people. We can start thinking about time and how well, not everything, but a lot of things in business systems is time-related. Things have to happen in certain order, things have to happen as a consequence of, etc. In this case, it's very explicit, of course. We have a very explicit expiration period. I should have called it expiration period here, right? I picked this example because time is explicit here. So in fact, we can make time more explicit. To me, even the passage of time is an event. So I would actually model explicitly 30 days have passed, and then that event, did I have a, yeah. So 30 days have passed, reconsideration period has expired. I model these as 2 separate events. This one is just the passage of time. This is how we react to the passage of time, right? Another way to look at it is, how do you model that an event should happen when nothing happens? If nobody has, there has been no actions for 30 days, how do you model that something should happen as a reaction to that? Just by modeling the fact that 30 days have passed, right? If you're interested in more details, I'm blogging about these patterns, by the way. So now I have this very explicitly. So now, if you look at this, yeah, now this bug is dealt, well, modeling gap or something is dealt with, that if at this point the customer has reconsidered, then here we will not clean up the account, right? And we're in this version. Sometimes, well, very often actually, here I modeled it as a branch. A better way often is to actually model the two variations of the process, right? I'm not going to do it now because it would take us too much time, but I just model every variation of the process so that I can clearly see what works and, you know, if everything works, if I have dealt with all the cases. So then there would be a version where expiration was scheduled, 30 days have passed, reconsideration period has expired, and then we just end up in, so we check the rule, don't close if the customer has reconsidered. The account was cleaned up, right? And then I would do another one below it, subscription was canceled. I copy the post-its, subscription was canceled, expiration was scheduled, reconsider, customer has reconsidered, 30 days have passed, reconsideration period has expired, don't close if the customer has reconsidered, nothing, nothing happens, and in the first one, account was cleaned up, right? So I have two versions of this process now. For every branch, I can model that. I don't do it always for every possible combination, but just enough to figure out if I have covered all the cases. And then I start experimenting. The beautiful thing, yeah, sure. Yeah, do I recommend introducing a comment for actions that the machine does? Is that your question? Yes, okay. Yes. Very often I do, because one way of looking at it is the machine automates things that a human could do. So I'm now trying to keep it compact for the presentation, and I only have 2 whiteboards. But often I do that let's imagine it's all humans, right? Every event is I notify somebody, and every command is somebody tells somebody else what to do, or perform some action, right? And then I would say, indeed, reconsideration period has expired. I would add a command saying close or cleanup, or let's call it cleanup. Leave it. Alberto says you can measure progress by the number of post-its on the floor. So cleanup account. Something like this, right? This is your question, right? So cleanup account. The nice thing about that approach is you make it very clear that there is an intention to clean it up, and there's a business rule that decides if it in fact can be cleaned up or not, and then the outcome of the decision is the event, right? So yes, I do this very often, and then basically what we're doing, the next step is deciding which of the blue ones are done by human users, by our customers, by ourselves, by the, maybe customer support or sales, or by the machine, right? I don't want to pay somebody to do this job because I can write a function for it. So, well, maybe I should show this first then. The next step I do in this kind of modeling is figure out how the rules make their decisions. In this model, here you would say it would have a flag is cancelled, and then if that boolean is true, then this rule says, oh, it is cancelled, so yes, I can clean it up. But I said in the beginning that structures or state are the consequence of everything that has happened before. We can now model that explicitly, right? We can say this decision here, don't close if the customer has reconsidered, depends on the fact that the customer has reconsidered, right? So this needs to know about that event in order to make its decision. Of course, we could still model that as we store the outcome of that. We store that as a Boolean somewhere, but this is now only a projection of stuff that has happened. But fundamentally, if you look at it, the decision depends on what has happened before. We're modeling the real world, right? We're modeling, well, not the real world. We're modeling how decision making happens in the real world, right? I do this because this thing has happened and this thing has happened. In more complex examples than this one, you would have a whole bunch of arrows sometimes. And these arrows are fundamental. This coupling is fundamental. So what for example, if I'm building a microservice, if I had, for example, the customer microservice and the account microservice, if I had drawn these structures too early based on the nouns, on the entities, I would now have an arrow that couples my account. No, what did I say? The customer and the account, yeah, or the cleanup or the reconsideration microservice. But in any case, if this is in a separate microservice from that, I now have coupling, right? I need some way that these two microservices talk to each other. The better solution, where we can create more autonomy, is if we look at the arrows. And so let's say we have, these are events and business rules, and we have a bunch of arrows here, things depending on each other, and here. So here there's no connection. So this and this can now be two isolated services, right? They can be autonomous. Whereas if I had drawn it like that, then there would be arrows crossing that boundary. So we'd have to couple the microservice somehow, either by exchanging events or by doing queries. Queries are more coupling because if I query something, it needs to be online at the time that I need that information. If something sends me an event, I don't need to be online when they send it to me because it can be put on a queue. And they don't need to be online when I process it because they've put it on the queue, right? That's temporal decoupling, right? So I now have a system not only for analyzing and understanding connections in my domain, but to use as a heuristic for finding more optimal boundaries for my microservices. Of course, there is going to be coupling. There is going to be things that need to know about each other, but I can think about how to minimize that. I can think about patterns to minimize that. In fact, I'm blogging about these patterns. For example, instead of, let's say, this process and this process, let's say that I need to know about that thing, and I need to know about that thing and that thing. That's a lot of coupling. I can come up with a new type of event, which I call a summary event, which is the summary of things that have happened in these events. And then I only need that summary event to start this process. And now this process only depends on something it already knows. So it's self-contained, right? So the only connection is once at the beginning. All the rest of the steps are done in this separate service, microservice, whatever, independent of the rest. So we have greater autonomy, greater decoupling, temporal decoupling, right? Also logic decoupling, because it needs to know less about the internals of this thing. Yes? Does that somehow, or do you need more examples? Right? Well, I'll give you one example. A new order is initiated, add a line item, remove a line item, etc. And then instead of, when we fulfill the order, order picking and packaging and whatever, and shipping it, instead of having to know everything about how that order was built, we emit one order at the end, right? That starts the whole fulfillment process. I'm modeling it exactly as it happens. They have discovered these patterns long ago. That's what an order is, right? An order is a message. It's an event. It's not a document anymore. It's not the artifact that we care about. It's the message. It's, hey, do this thing. Send these items to this customer. That's a command, right? And business works that way. They hand over this paper. Well, in the paper world, they used to hand over this paper document to the next department, and they would deal with it, right? They wouldn't phone back and forth all the time. So what's the next item in the order? Okay, that one, I'll get it. What's the next one? Oh, then they decided that they wanted 2 of those. Okay, I'll get another one. That's not how it works, of course. If you look at the world that way, then you find better separation between things, because things that you would maybe in structural models, I said the huge objects where everything starts to cluster together, like the car in the car rental example. If you look at the processes, you draw the arrows. Thanks to the arrows, you start seeing things that clusters, things that can be separated. Instead of a car object, you might have a car maintenance object, a car rentals object, car description with stuff that is not, which is just like the color and the brand and the whatever, as opposed to putting it all together. I want to show you, how maybe that will help to convince you. Show you how temporal modeling helps me to find bugs. Has anybody spotted the bug?
Yeah, the don't close customer account is reconsidered, so it doesn't have the correct. So it's not stated correctly. I think is that right? Is that the bug?
That's not the one I'm looking for. It's possible that I did it. Don't close if customer has reconsidered.
It's the customer has reconsidered, but so it should say that and it's expired as well.
Yeah. I agree. Well, in a sense, it doesn't, because now this one is only triggered when. No, you're right. So I should add that there. Exactly. Sorry. But there's ways to express it where it's not in the rule, because the rule is only triggered when the event happens, and then the thing I'm looking for. So imagine, what I was saying, that I make multiple versions of this process to explore it. With post-its, you can start moving them around and adding more, and this is the cheapest way of. After you've done this modeling, everything in software becomes more expensive. The moment you start building or prototyping, it's more expensive. By the time you have built your prototype, I have, iterated over 15 models. For example, I would, what if this happens twice? That sort of question. Like, what if this happens before that? And that's very cheap. I can discuss it with business experts instead of very technical discussions with programmers. I can talk to the domain experts and say, yeah, but what if this thing happens first? Oh, that never happened. What if the customer pays for the invoice before we send the invoice? Oh, that never happens. Oh, actually, that happened last week. Okay, what happened? Well, we have a customer that we bill every month, and we were late with the invoices, and they paid us already, but because there was no invoice, we couldn't match the payment to the invoice, so we send them reminders. They got angry. There was a huge drama, etc. I could have discovered that much earlier by just saying, what if this happened before that? Right? In this case, or questions like, what if this happens twice or 1,000,000 times or never at all? Right? So here, what if it happens twice? So normally I would make a new lane, but subscription was canceled. Expiration was scheduled, right, for 30 days. The customer reconsidered. Customer has reconsidered. 30 days have passed. No, not yet. The subscription was canceled again. So we're now, sometimes I add the timeline as well. So this could be day 1, 2, 3, 4, and then here we are at day 30, of course. So on day 4, subscription is canceled again. In this model here, the structural model, 30 days pass. The flag is cancelled because it was cancelled again, even though they have reconsidered. So the flag is cancelled, true, false, true again. 30 days pass, and this stuff happens, and we clean up the account. But from the point of view of the second cancellation, we have now cleaned up the account at day 26. That's a bug, because there were no 30 days. Well, it might not be a bug. But at least we now have a way of discussing this. These are hard things it's easy for you now because I presented to you this problem to you using this model. So you have to use your imagination now that this might have been much harder to explain to you if I hadn't shown you a temporal model of it, right? Because then you have this sort of discussion, yeah, but what if, and you're trying to explain, there's no visualization.
What I understand is it's a formidable way to have a design that enable you to be able to reconsider the business logic without changing the way you are storing what you are seeing in the real world.
Yes.
The thing is, the only drawback I see is you have to store a lot of data.
Yes. So I'm not saying you have to. This could be you could model it this way, and then go back to your traditional ways of building things, but you will have a better understanding of what to put together and what not. So I actually use half of my clients are traditional legacy and object oriented and whatever. The other half is doing event sourcing. What you're describing is called event sourcing. It's we store every event, and then the structures are just a consequence of that, right? So event sourcing is temporal modeling applied, in a sense.
Ideally, you don't have any structure. The only structure is events themselves.
Yes, except that would be very, yes, I agree. That would be very expensive indeed, because if I need to make a decision based on events since the start, since 3 years ago, I would have to reread that entire event store to make the decision. That's not very practical. So what we do is when events come, we change some state somewhere, we store some structure somewhere, right? And then we still depend on that state to make decisions or to present it in a user interface or whatever we want to do with it. However, we now have, because we have, the events are the single source of truth now. That's my definition of event sourcing, right? It's a log of everything that has happened. And the log itself, the event store, the history of events is the single source of truth for the system. So every structure that we derive from that is a projection, is a cache, basically, right? We could even throw that away and rebuild it. We could build different versions of it. I could look at, let's say basket. Item was added, item was removed, item was added, item was removed. Item was added, so now the state of the basket, I can make a projection of that says the state of the basket is one item. Right? But I can make another projection that says, you've removed this thing twice. That's very good business information, because maybe I have a hypothesis that if you remove the same product twice from your basket, it's because you really want it, but you're sort of in doubt about the price. So I give you a little discount, push you over the edge, done. Right? So the event store itself has business value. It tells us everything that ever happened. And not only that, I could probably, well, not me, somebody who knows mathematics could probably prove that it's more powerful fundamentally, because if I have all these events, I know everything that happened over time, I can project any possible state. But if I store state, I cannot reduce the whole event store or the whole event history. So it actually gives you a lot of agility. When there's always talks, I think there was a talk here, I didn't see it, but about event sourcing and the benefits and the drawbacks. I think the chief benefit that people underestimate is how much agility that this gives you, right? Your event store it's never wrong. You never have to change the schema of an event store, because these things have happened. What we do in structural models, in state models, is you design a structure and then you think, oh, actually this other model would have been better, this other structure, or I need to store other things. Then you need to do migration of your database, right? Migration, what we do in a migration is really trying to fit the existing data in the new model as if it has happened in that model, right? We're lying basically about our own history. With events, you never have that, right? You just make new projections, new caches or new interpretations, right? So yeah, we were talking about the bug. Is that obvious now? So if we cancel and reconsider and cancel, and 30 days pass, the first 30 days, there's another, actually, I wasn't very complete here. Subscription was canceled again, so we actually have two. There's another scheduled here, right? So we have this one, we have this one. This one ends on day 34, but the actual cleanup happens on, well, let's put, here, day 30. The actual cleanup happens on day 30, and then this should have been here. The second cleanup, which cannot clean up anything because it's already cleaned up, happens at day 34. But the bug is that we've cleaned it up too fast, right? And the customer or the salesperson thought, I had 4 more days to convince this customer. I finally convinced them on day 31, and we check and it's gone, right? That's a bug. Or you talk to the business and, oh, that's fine, whatever, that might also be the answer. There might be good reasons to that. But the point is that we can visualize that now and understand it. And everything, our model was not wrong. I mean, we were missing parts. The rule needs to be smarter, or we need to unschedule That could be a solution. Unschedule the expiration, or make the rule a bit smarter that it should make sure that it's always dealing, because there's two arrows now, right? There's an arrow going from to has expired and to this has expired as well. And the rule could be, always use the last one or look at the last one, something like that. There's ways to solve it now, and we could, spend a modeling session on that, but we're out of time. But the point is that we detect these kind of bugs more easily now. It's not just about detecting bugs, it's just about understanding the actual maybe your system was actually behaving correctly, but nobody knew that. To me, if I ask you a question, how will your system behave under these circumstances, and you don't know, then I consider that a bug, right? It's a specification bug. You don't know how your system, it might behave correctly, but it behaves correctly accidentally, right? If it behaves correctly accidentally, that means that it might also stop behaving correctly accidentally when you do another change. Somebody changes something, there's no test, there's nothing, no specification that tells you how it should behave, so nobody tests for it, nobody knows it, you break the system. I think a lot of bugs happen that way, where things just, they seem to work and then they stop working. A bug got into our system. No, it's modeling depth, right? It's a depth of understanding how your system works, or how it should work, right? I think we're more or less out of time. Do you have time for questions? Not at all? Okay. Well, thank you very much for joining me on this experiment. Thank you.